Hi, this video will explain about energy flow through ecosystem. So the learning outcomes is for students to be able to explain the energy transfer and then able to calculate energy loss in each trophic level. What is food chain? It is a chain along which energy and matter is transferred from one trophic level to the next trophic level. So food chain begins from producer through a sequence of consumers. Trophic level is the stage or the level, the position that an organism occupies in a food chain. Usually there are 4 or 5 trophic levels. This is an example of a food chain that shows paddy eaten by grasshopper, and then grasshopper eaten by bird, bird eaten by snake, and snake eaten by eagle. The arrow here shows eaten by. So the position, let's look at the position. The paddy plant is paddy plant is at the first trophic level number 1, which the role of the paddy is as producer. Paddy is eaten by grasshopper that live in the trophic level 2, which becomes the primary consumer. The first one that eat on the producer is the primary consumer, and it goes up to the secondary consumer, which is the bird that stay at the trophic level 3, occupy the trophic level 3. And then we have the snake as the tertiary consumer that consume on the bird, occupying the trophic level 4. And the last one is the eagle, occupying the trophic level 5, that becomes the quaternary consumer. There are two types of food chain, the grazing food chain and the detritus food chain. So you can see the difference between grazing food chain and the detritus is the organism that occupy the first trophic level. In grazing food chain, the organism that occupy the first trophic level is the producer, the plant, or the photosynthetic organism, the plant. While in detritus food chain, the organism that occupying the first level of the first trophic level is the detritus. Detritus is the dead organic matter. So detritivore becomes the first consumer, and then the prawn, the lobster, the crustacea that eat on the detritivore becomes the secondary consumer. The fish that eat on the prawn is the tertiary consumer, and the otter that eat on the fish is the quaternary consumer. So grazing food chain begins with producers, the autotrophs, which eaten by primary consumer, which is herbivore or the omnivore, and then eaten by secondary consumer, which is the small carnivore, and then the small carnivore eaten by tertiary or quaternary consumer, which is usually a larger carnivore. Grazing food chain are the dua. They are divided into two types. First, the predatory food chain, and then we have the parasitic food chain. Predatory food chain, as we can see from the diagram, it shows that the organisms at each trophic level of predatory food chain gradually become larger in size. While in parasitic food chain, because parasites are usually smaller than the host, so parasitic food chain involve parasites, and the organisms at each trophic level gradually become smaller in size. You see, the nematodes eaten by the bacteria. Bacteria is smaller than the nematodes. In detritus food chain begins with that organism, which we call it as detritus. That is the first trophic level, which will be consumed by primary consumers. We call it as detritivores. Then the secondary consumer eat on the detritivore, and then large carnivore will eat on the small carnivore. You can see the examples of the detritus food chain in this slide. So dead leaves are eaten by earthworms. Dead leaves is the organic matter, dead organic matter. And then earthworm eaten by small bird, and then hawk eat on the small bird. Okay, let's look at food web. First we have the food chain, and more than one food chain interact with each other to form a food web. So food web is a complex network of food chains that are interconnected with one another in an ecosystem. Why food web is more realistic? Because a particular organism feeds on more than one trophic level. For example, an omnivore like human. Human can become the first consumer, which, for example, we eat mustard, we eat bayam, kan, spinach. And then we also become a carnivore. We also we are omnivore, so we become a flesh eater. We eat on the chicken. Chicken is the first consumer that eat on chicken can be a first or secondary consumer. Okay, like us. First we eat on the paddy, and then so we become the first consumer. If we eat on the grasshopper, then we become the secondary consumer because grasshopper eat on the paddy. Okay, there is the difference between food chain and food web. You can look at your notes. Food chain is a chain along which energy and matter is transferred from one trophic level to the next, while food web shows a complex network of food chains. Food chain shows linear feeding relationship, while food web shows an interconnection. Ecological pyramid. So what is ecological pyramid? It is a diagram that shows approximate amount of mass, organisms and energy within each trophic level in a food chain. So from a food chain we can construct an ecological pyramid based on three items. Either mass, based on the mass of the organism, the number of the organism in each trophic level, or the amount of energy in each trophic level. So we will have three types of ecological pyramids, which are called as pyramid of number, pyramid of biomass, and pyramid of energy. Let's look at pyramid of number first. Pyramid of number shows the number of all organisms at each trophic level in a food chain. So usually a pyramid, it has a larger bottom and narrower or smaller upper part. Okay, because usually the number of producers at the pyramid base are larger. We have more producer than the other trophic level. Okay, at the top, the organisms are usually larger in size but smaller in number. We have less organism at a higher trophic level, but the size of the organisms are larger than the lower trophic level. The example of inverted, there will be a situation that we can find that pyramid of number is inverted. For example, in predatory food chain usually shows a larger organism at the upper part of the trophic level. As it goes higher of the trophic level, the size of the organism becomes larger. See, hawk is larger than small birds. Small birds are larger than caterpillar. Okay, but why the number of tree is less than the caterpillar? Logically, a tree is one tree, but it has a lot of leaves. So caterpillar, we can find more than one caterpillar on a tree. Is it? Do you understand? So it couldn't be only one caterpillar in each one tree, or more than one tree. For example, there are 4 trees but one caterpillar. No. So in terms of number, the pyramid can be inverted based on the type of the producer. If we have a grass, a paddy must be cultivated in a large amount. So it's not logic to have only one paddy plant, kan? So this is an example of an inverted pyramid of number. Okay, another type of inversion can be seen at the second diagram that shows parasitic food chain, which shows paddy has a larger number than the rats, but the number of the rats is less than the number of the fleas. So the inversion is more unusual because the smaller number is at the middle of the trophic level. Because as we know, paddy would be more than rats. Okay, while fleas cannot be less than rats because one rat can be infested by 100 of fleas, and then fleas will be infested by a lot of parasites. The advantage, the things that we have to identify or we need to memorize about pyramids, ecological pyramids, are their advantages and their disadvantages. The advantage of pyramid of number is the number of the organisms, especially the larger animals such as elephant, human, can be counted easily. While and then the pyramid of numbers, so when the number can be counted easily, the pyramid of numbers can readily be constructed. But the disadvantages, we have to we cannot we can't take notes on the changes in size of the organism during its life cycle. For example, human. We can only identify the number of human, but we cannot identify whether the human grow or not, grow old, or becomes larger in size, or becomes heavier. Another thing is about problems of classifying organism and grouping the organism into their different trophic levels, because there are organisms that can occupy more than one trophic level. And then difficulty in counting small organisms that are very large in numbers. For example, the ants, okay, the bees. Pyramid of biomass. Pyramid of biomass shows the total mass of all organisms in each trophic level. So this is a normal pyramid biomass. Most biomass pyramid narrow sharply from primary producers at the base to the carnivores at the top. A very small mass at the top. Sometimes an inverted biomass pyramid can be produced. For example, the biomass of phytoplanktons are less than biomass of zooplanktons. Okay, why? First, because phytoplanktons are smaller in size. Logically, they can be larger amount than the zooplankton, but because they are small and they are much more lighter than the zooplankton. So in terms of number, they might be larger, but they are lighter. So their biomass are smaller. And also, they are rapidly consumed by zooplankton. So they are produced in large number, but they can easily reduce. The number can easily reduce in a short time. So usually we have an inverted pyramid of biomass, which if it includes the relationship between phytoplankton and zooplankton. The advantage of pyramid of biomass gives better indication of mass of organisms and the flow of energy throughout different trophic levels of the food chain. But the disadvantages, there will be problems encountered during when we want to determine the biomass, because it involves the killing and drying of certain organisms, because we have to obtain the dry mass, not the wet mass. We cannot simply just weigh the weight of the organism, because we have to consider the amount of water in the organism. So we have to remove the water first by drying, so the organism will be killed. Also, the biomass may change with time and in different organisms, such as human like me. Last year, I'm maybe 2 kilograms lighter than this year. Okay, so my biomass may change. Even in the morning when we wake up, our biomass is slightly less than when we end the day. Okay, because we eat, we drink, it all contribute to the change of our biomass. And also, a biomass does not show the productivity of the organism. Pyramid of energy shows the energy content of all organisms in each trophic level. It shows the size of each block is proportional to the net production of each trophic level, which is expressed in energy units. And it also shows the loss of energy with each transfer in a food chain. Only 10%, almost 10% of energy within one trophic level will be transferred to the next trophic level, and this energy can never be inverted. And this pyramid, the pyramid of energy can never be inverted. So pyramid of energy for each trophic level shows the energy per unit area per year. The advantage of pyramid of energy, it is the most accurate method of representing feeding relationship. But the disadvantage is it is difficult to obtain energy data, and the energy values for given masses of organisms are needed. Energy transfer along the food chain in an ecosystem. The original source of energy is from the sun. Okay, out of the energy that produced by the sun, 40% of the solar energy that reach the earth will be reflected immediately. Okay, because our earth are layered by some layers, the ozone and everything. So the sunlight from the sunlight before it reach, it will be reflected. So this is 40%. 15% more will be absorbed but then converted to heat in the atmosphere. Another 45% will reach the Earth's surface, penetrate the ozone layers and reach the Earth's surface. This 45% usually used by plants in photosynthesis. But the producer, the plants, of any photosynthetic organisms will only trap 1 to 5% of the light energy received. Out of 45%, only 1 to 5% will be trapped for photosynthesis. Okay, for biomass production. Primary consumer feed on plants and producers. So only 10% of the biomass production from the producer will be transferred to the primary consumer. Because only 10% of energy is transferred to the next trophic level, another 90% of the energy will be lost to the environment. So from herbivore, the energy is lost through respiration, excretion, and also ingestion. The energy lost in respiration cannot be transferred to other living organisms, but the energy lost in feces and urine can be transferred to detritivores or decomposers. The secondary consumer feed on primary consumer. The energy will be then transferred from second to third trophic levels. Okay, food chain cannot consist more than 5 trophic levels because large amount of energy is lost during each transfer between the trophic levels. So only 10% of energy is transferred to the next trophic level. There are more energy that is lost as heat energy. And then the energy from the trophic level also lost through respiration, excretion. And then, so each trophic level receives less energy. After the 5th trophic level, only small amount of energy is left. So the energy is not sufficient to support the organisms in the next trophic level. Reason for reduction of energy at each trophic level, starting from producer. Because some of the material is not consumed. Example, when we eat the chicken, we leave out the bones. We eat the producer, we do not we unroot the producer, for example the spinach, but we did not eat the plant roots. Some of the materials is not digested, for example the cellulose, the fiber, the cereal, the fiber. We human do not have the cellulose, the enzyme that can digest the cellulose, so the material is not digested. Another reason is energy is lost through excretion. We urinate and then we poop. The ejection, the feces contain energy, heat energy. Also energy is lost through respiration. Okay, the formula of energy loss and energy transfer. The initial energy minus final energy and divide by initial energy by percentage. Percentage of energy transfer, the final energy, divide by the initial energy and by percentage. Okay, thank you.